G'day and welcome, Pure Maths 3 students, to week 7 of maintenance, where we will be looking at some past exam questions from algebra, logarithmic and exponential functions, as well as trigonometry. And I have a question from an old textbook on differentiation, where we will look for the first time in maintenance at the quotient rule. Okay, so the first one here, we have a polynomial 2x cubed minus x squared plus ax minus 6, where a is a constant denoted by px, and we know that x positive 2 is a factor, which means that, and we need to find the value of a. We know, therefore, since x plus 2 is a factor, we know that p minus 2 should be equal to 0. And so all we need to do is 2 times negative 2 all cubed minus negative 2 all squared plus plus a times minus 2 minus 6 ought to equal 0. And all I'm doing here, guys, is just placing for every value of x in the formula, just putting in a minus 2 there. So we get negative 8, so it's negative 16 minus 4 minus 2a minus 6 equals 0. And if we just, what do we get? Negative 26. Negative 26 equals 2a, and a should be equal to negative 13. I think that's what it is. Let's just do a quick check on that. So we get negative 2 cubed is negative 8. Negative 8 times 2 is negative 16. That's fine. The next term would be negative 2 squared, which is positive 4, and a minus in front of that. We get a negative 2a, which I'm happy with, and a negative 6. We gather all that stuff together, negative 20, negative 26. Yeah, I think a must therefore be negative 13. Okay, now, when a has this value, we've got to factorize it completely. Well, we know that x plus 2 is a factor, so if we just use long division, we should be able to find the other factors. Now, we find a is negative 13. Alright, so theoretically, we should just be able to do this and find the other factors. So I'm going to multiply first of all by 2x squared. And then that will give me 2x cubed plus 4x squared. And then we just take those away. So we get a 0 and then a minus. So that should be minus 5x squared, I think. Then we bring down our minus 13x. And so I'm just going to times by minus 5x. And so I get minus 5x squared minus 10x. So I'm taking away that whole thing. And so you get negative 3x. Bring this down, minus 6. And then I need a minus 3 here, I think. I think that's right. Yes, so I get a minus 3x and a minus 6. And we subtract that away, and then we get 0. So that means that as well as x plus 2 being a factor, 2x squared minus 5x minus 3 is also a factor. And we can further factorize that, because it says to factorize completely. And if I factorize that, I think I should get 2x and then x here, minus 3 over here, and plus 1 here, just using factorization. And that should be the answer for that. That looks perfectly acceptable to me. Right, now moving on to the next question, which is a logarithmic and exponential functions question from that side of our syllabus. The first thing I would probably do is what would I do? I will take a log of both sides. So I'm going to go log, and I'll just do two things at once. I'll use my log rules to simplify it to log, and it'll just be base 10 I'm going to use, so I won't put that in. And then on the other side I'll have y equal, I'll have y log 2.5. And then the next line I can go x over y. I'll divide both sides by y equals log 2.5 over log 1.25. Now, this should give us our answer, so I'm just going to chuck this on the old calculator now. Log 2.5 all over log 1.25. And now this is giving me 4.11 to 3 significant figures. Okay, the next one is one of these really annoying ones. Okay, what are we plotting? We're plotting x squared against ln y. So we're going to take ln of both sides. So we get ln y, and then we get ln a e to the minus k x squared. I hope you can't hear my 3-year-old throwing a tantrum. It seems to be every time I do a video, doesn't it really? Ln y, and then I'll use my log rules to separate it out. Ln a plus ln e to the minus k x squared. And what are we going to do here? Maybe I will go ln a. Now, ln e is like it's just 1. So I could rewrite it as minus k x squared, I think. Okay? Right. Now, what do I know? Well, I'm plotting ln y against the x squared values. And I know that the value of k is equal to the gradient. Okay? Because this is like our intercept and this is our gradient. So in this case I'm going to say minus k, or just, yeah, minus k, or maybe just k. K is equal to, oh okay, let's do minus k, sorry, is equal to negative, and sorry, we'll change in y over change in x. So the original y, so 0.32 minus 0.76 should be all over 1.69 minus 0.64. And when I chuck this into my calculator, 0.32 minus 0.76 all over 1.69 minus 0.64. And then that means that k, in the end, k is equal to 0.42 to 2 dp. I'd save my unrounded answer. Now, if I want to find the value of ln a, I can now chuck in some values. So I know that ln y, for instance, is equal to this bit here. So I can go 0.76 equals ln a minus k, which I've found in the previous question, times, and my x squared value is this one here, 0.64. And then we have everything known, so we can get ln a by itself by moving the minus k times 0.64 across the other side. So when I do that, and I add it to the 0.76, I'm getting 1.03 to 2 dp. Okay, I have a track record of getting these wrong, just doing dumb things, so I hope that's okay. Alright, moving right along, we've got a trigonometry question here, and this is, we're trying to solve this, and you can see clearly that we're going to be using the addition rule. So we're going to use this, and we've also got to use the sine addition rule, which is this one here. Okay, so on the left hand side, we're going to go, that is equal to cosine. Now, so we're going to plus here, so it's going to be cosine theta cosine 45 minus sine theta sine 45 equals, now on the other side we'll have 2, and I'm just going to put a big bracket here. Sine theta minus sine 30 would be sine theta cosine 30 minus cosine theta sine 30. Okay, so I'm just using this and this. Now, a cosine 45 is square root 2 over 2. So we've got square root 2 over 2 cosine theta. And then sine 45 is the same. Oh, that's right. Duh. Minus square root 2 over 2 sine theta equals, now cosine 30 is square root 3 over 2. So it'll be 2 into square root 3 over 2 sine theta. And sine 30 is 1/2, there we go, minus 1/2 cos theta. Okay, now we'll expand the bracket in the next line. So I've got square root 2 over 2 cosine theta minus square root 2 over 2 sine theta equals square root 3 sine theta minus cosine theta. Now what I'm going to do is I'm going to gather my sines over to one side and my cosines over to another side. So if I add the cosine to the left hand side, so I'll get 1 plus, and then I'll have square root 2 over 2, and that gives me this. It gives me 2 plus square root 2 over 2 cosine theta equals, and then if I add the square root 2 over 2 sine theta to the other side, so that I'll have square root 3 plus square root 2 over 2, and I'll end up getting 2 square root 3 plus square root 2 over 2 sine theta. So I'm just chucking this on my calculator to help me. Okay, now at this point, I'm just going to get rid of this because we're running out of room. I've used that rule already. Okay, now what we're going to do at this point is I'm going to divide both sides by cosine. So on my right hand side, I'm going to have sine theta over cosine theta. And on the left hand side, I'm going to move this, divide both sides by that. So I'll have essentially this divided by this. Now when I do that, you'll see that's like flipping and timesing by the reciprocal. So when I do that, I'll end up with 2 plus square root 2 over 2 square root 3 plus square root 2. Now at this point, we can say, we'll flip that. This here is tan theta. So I'm going to say tan theta equals, and then I've just stick this in here again. Right, that's what it equals. And so therefore theta should be equal to the inverse of this. Okay? Right. So I'm just going to save a little bit of room because I'm really running out of room here. Get rid of that, get rid of this. I'll just move this up. Okay, so there we go. And let's do this on our calculators. So inverse tan, and we got 2 plus square root 2 over 2 square root 3 plus square root 2. And away we go. And I'm getting, as a result, theta is equal to 34.98 or 35.0. Now, with the tan graph, you can see here, this is 180, and we've got a result here, and you know that there's no other results in the 0 to 180 range, so we can just leave it at 35.0. Okay, hope that makes sense. Now, last one, differentiation, we're going to use the quotient rule. So I'm not sure if we'll have talked about this in class or not, but here's how you do it with this equation here. we want to differentiate this. It's quite small, isn't it? So what we'll do is we assign something to be u and something to be v. So we'll say u is equal to 2x, and then we differentiate that with respect to x, so that's 2. Then we go v, and we'll make v is equal to the bottom. And so dv dx is equal to 3. And then we pop it into this formula. So dy dx is equal to v, which we've found to be 3x minus 1, into du dx, which is 2. So I'll put a 2 in front of that. Minus u, now u we found to be 2x, into dv dx, which we found to be 3, and all over v squared. Now v is this, so we're just going to square that. Now all we need to do is just expand everything out. So we get 6x minus 2 minus 6x all over 3x minus 1 all squared. Okay, and now we can simplify even further, and we should get negative 2 over 3x minus 1 all squared. And that would be that. So I hope this has been helpful to you. Please keep on letting me know if you've got any problems or you want some extra explanations. Happy to help out. Alright team, God bless.